Good afternoon, everyone. We are going to continue with the unit number 4, that is IoT protocols and security. Okay, so in the last sessions, we have discussed regarding the protocols regarding the IoT. IoT protocols we have covered. Now we are going to continue with the IoT security. Okay, so first we will see IoT device life cycle. Okay, so there are 4 stages in this life cycle, that is boot up, initialization, operation, and update. So these are the 4 stages of this life cycle. So first one is your boot up. Boot up means in that where the device is loading the firmware. Okay, first this firmware is loaded in the boot up process and starts working as we are defining the operations. Okay, then we have to initialize. We have to initialize. In the initialization process, we have to establish the connection and we have to synchronize the data and we have to read the configuration based upon this device. And the third step is your operation. The device has to perform the operations that are allocated or the task is allocated to the device continuously. And in the fourth step, that is update. So we have to update the firmware. If any new firmware comes into pictures, we have to again reboot the device and we have to load that new firmware. Okay, so these are the 4 stages in this life cycle of the IoT device. We will see one by one. So first one is your boot up process or boot up stage. So in that we have to first firmware integrity check. That means we have to ensure that that firmware has not been modified. Okay, that firmware we are having, it should not be modified or tampered by the other personnel. Okay, so the best method is to implement an integrity check by embedded checksum or secure password. So we have to provide that checksum or we have to provide that password to that device. Okay, so that means secure boot process. So that means we have to encrypt that firmware with the public key or private key encryption or certification. To secure that boot up process, we have to provide or we have to encrypt that firmware with the public or private key. Then second one is your initialization process. So it provides the AAA protection. So first we have to use the proper encryption to avoid that user hijack. That means we have to provide the encryption using the public key or private key. Then default account credentials that appear in many IoT devices. So it is the best to have an activation process that requires end user to change the default password. So we have to provide the uh, some methods to change the default password to the user. Okay, based on this strategy. Then key certification protection. As we are using that public or private key certification, we have to provide the protection to that. That means we have to use KMS or CMS. That means we have to use key management system or certification management system to protect that encryption and decryption of that keys. Or to store those keys, we have to store that keys in a TPM, that is trusted platform module. This is the second step of IoT device lifecycle, and it includes the communication protection. That communication protection means that communication between device and device or device to device or device and the internet or the device and the user interface. That interface may be from the your mobile apps or web apps. Okay, so that interface or that connection should be encrypted by using the HTTPS, AES. Different strategies are there to encrypt that. Okay, so that connection should be or the communication from the device to device or device to internet or from device to user interface should be encrypted. Then identity protection. So to prevent the fake identity, we have to prevent the fake identity within that communication group. So it is necessary to make sure that that communication object is certified by, or we have to use for that KMS or CMS. Okay, KMS means your key management system and CMS is your certification management system. Okay, then third step is your operation step. Okay, so in the operation steps, we have to perform or device has to perform the task that is allocated by the app admin or remote application. So in that we have to remove all the backdoor debug user accounts. That means we have to remove or we have to take care about the fake accounts. Okay, from the several studies we have found that many IoT devices keep those accounts for debugging purposes. So we have to remove that. Okay, so during this operation stage, that IoT device may still associate with these new devices, users or clouds. Okay, so we have to remove the fake identity, or we have to remove these fake accounts from this uh, in this stage. Okay, that means we have to remove all the backdoor debugging user accounts. Okay, then we have to monitor. That monitoring stage is there. That means we have to monitor the operations. What are the normal or abnormal operations are going to perform by this device? So what operations occur? That means we have to provide the warning to the backend or the end users. Okay, that means we have to monitor, or we have to detect that abnormal operations from this device. Then integrity check. Integrity check means that is, we have to check the runtime integrity. That checks, or that integrity checks can prevent the device from being compromised during the operation. Okay. Then risk management. There is a risk management, that means it uses a method like virtual patching or host IPS to reduce the risk before firmware over the air, that is, or it triggers. Okay, so that we have to remove that. We have to avoid that risk in the operations. Then last stage is your updations. That means if any new firmware comes into picture, so we have to again reboot the device, and we have to start the new firmware. Okay, so before this FOTA triggers, that means firmware over the air triggers, the new firmware needs to be encrypted and check to make sure that that next life cycle will be performing a secure boot up. That means if any new firmware comes into picture, we have to again reboot the device. Okay, so these are the four stages of the IoT device life cycle. Okay, so it is possible that there are different attacks can happen in this process. Okay, so these attacks can be active attacks or passive attacks. Okay, these are the two categories of these attacks: active attack and passive attack. So active attacks are in which the attacker tries to manipulate, interrupt, or modify the valid data of the system. Okay, so in the active attack, the attacker tries to manipulate the data. Okay, it will change the data, or it will interrupt or modify that valid data from the system. So examples of that active attacks like DOS attacks, like denial of service attack, in which that users are not allowed to access the services due to request overload by attackers. So in that we have to identify the theft, or we have to identify, or we have to unauthorized access to services. That means we have to identify the unauthorized access to the system. Okay, and next one is your passive attack. So in the passive attack, attackers only spies over the, sorry, overall monitors the data transmissions. That means attacker just monitors the data flow. Okay, over the network. Attackers never change the actual data in the passive attacks. Okay, so this is the difference between this active attack and passive attack. Then see the typical IoT infrastructures are there, like we are having the remote control application. Okay, that means the admin side. It uses the remote control. That means it uses the public internet, and we are having the control server. Okay, all the communication happens from this server, and we are having the configuration application user. Okay, that means we are having any IoT devices that uses the public or private internet. Okay, and that configuration applicant can configure the control server, or configure that, or update the firmware. Okay, so this communication happens using this public or private internet. That means remote applicant can send the request, or going to perform some operations by using this control server, and sends command to the IoT device. Okay, so see the callback and wait commands, wait for commands. Okay, this is the typical IoT infrastructure. Okay, so there are several problems uh, there in the IoT security. So at IoT security, that means we know that IoT connects all the devices in the surroundings and provide a unique solution. Okay, so there are different security issues are there, like addressing, authentication, and underlying embedded security. Okay, so IoT devices in house such as like AC, refrigerators, washing machines are accessible over the internet, very poorly maintained in aspect of security. Okay, so there, if we are going to access that uh, devices over the internet. So we have to provide some security. Okay. So privacy of these devices and security over the data, it transmits very crucial. So to avoid this scenario of this authentication and authorization are essential. Okay, so because of these issues, we have to maintain the security for this IoT. That means IoT security is must. So these are the different problems of IoT security. Like initial design was for private communication of this IoT, or the only for private communication network. Then it moves to IP network and later on the internet. So there are several changes are there. So we have to provide the security based on this design. Then firmware updates are hard or nearly impossible after installation. So as we see, I've seen that the design of this IoT changes over the era. Okay, so we have to provide the security for that, or that we have to work on these updates. So started with basic security, then found the security flaws in the previous system, then attach more complex security requirements later on. We have to provide the securities. Okay, so see the problems like fake control servers are there. What happened with the previous IoT? So fake control servers are there, attack on the device ports if it is open, attacks on the server ports, steal the credentials, then inject bad configurations on the server, then sniff data on private networks. So these are the some problems regarding this IoT security. So we will see these problems one by one. The first one is your fake control server, typical attack. Fake control server. Here you can see that in the initial setup, we are having a control server. Okay. Then remote, we are having our basic system, like we are having remote control application, we are having this control server, and we are having a IoT device for the communication. But what happened in the fake control server? The attacker having their own server, or it creates a fake control server. So this IoT device, instead of communicating with the original control server, because of this attack or this fake control server, this attacker or this IoT device is going to communicate with the fake control server instead of original control server. Okay, so this is the problem regarding this IoT device. Okay, that is fake control servers are there. Then attacks on device, or attack on device open ports. Okay, so here you can see this attacker is there. Our basic system, basic IoT system is there. So attacker can communicate directly to this IoT device if that ports are open. Okay, then attacks on server open ports. If the server ports are open, then this attacker can directly attack on the control server, and after attacking, it will manage all the IoT devices, or that attacker can handle the IoT devices, and that remote applicants are away from this attack. Okay, so they don't know about what that communication happens behind this control server. Attacker can attack with this control server, and now after attacking, this attacker is the remote applicant. Okay, then steal credentials. Steal credentials means attacker can directly steal the credentials of this remote user, and that attacker can act as a remote applicant, and he or she can handle this, control this control server of entire system. Okay, that means attacker directly steal the credentials of this remote user. Then next type of attack is or the problems with the IoT security is attacker can inject bad configuration or firmware. That means it will inject the bad configuration with the control server, or it can inject the bad configuration or firmware with this IoT device. Okay. Then next attack is your sniff data on private network. So here, as we have seen that IoT device is going to use the private network. So this attacker can sniff the data, or it will change this data whenever this IoT device is going to send the response to this control server to the remote applicant. At that time, this attacker can change this data. The data is going to be sent by, or data sent by this IoT device. The attacker is going to change the data and transmit that data to the control server, and this data will be, or this data is received by this remote applicant. So it is not the actual data that device is going to be sent. Okay, so this data is from this attacker only. Okay, so these are the problems regarding this IoT security. So there are different IoT vulnerabilities are there based on these problems. Okay, like information manipulation is there, unauthorized access, DOS attacks, DDoS attacks, theft of resources, information disclosure. Okay, then insecure web interfaces, insufficient authentication and authorization is there, insecure network services, lack of transport encryption or integrity verification, privacy concerns, insecure cloud interface, insecure mobile interface, insufficient security configurability or insecure software or firmware or poor physical security. So these are the IoT vulnerabilities based on these problems. Okay, so we will see these vulnerabilities one by one. First one is your insecure web interfaces. So it will cover the IoT device administrative interfaces. So what are the obstacles in these vulnerabilities? Like default username and passwords are there. There is no account lockout. Okay, so vulnerabilities regarding this XSS, CSRF or SQL injections. So what is the solution for this? So we have to allow default usernames and password to be checked. Okay, so we have to check these default usernames and password, and we have to enable the account lockout. So the it will conduct the web application assessment if we are going to enable this account logout. Okay, so we have to allow default usernames and password to be changed. Okay, so that means that applicant or this user can change the default usernames and passwords. Okay, see the web insecure web interface like accessories, cross-site scripting and cross-site request forgery and SQL injections for this web application assessment. Okay, and next vulnerability is your insufficient authentication and authorization. It covers all device interfaces and services. So obstacles for this vulnerability is like we are having previously we are having weak passwords, password mechanisms, password recovery mechanisms are insecure, and there is no two-factor authentications are available. So we have to provide or we require these strong and complex passwords. Then we have to verify that the password recovery mechanisms are secure or not. Then we have to implement two-factor authentication if it is possible. Okay. So here two-factor authentication means it is a method of confirming the user's claim identities by using a combination of two different factors, like something they know, something they have, something they are. So the example of two-factor authentication is like withdrawing of money from the ATM. So only the correct combination of bank card, okay, and the PIN number. That bank card is like something user carries, and that PIN that is associated with that user. Okay, only user knows this PIN. So the combination of these two allow the transaction to be carried out. Okay, that is the example of two-factor authentication. Then next vulnerabilities in IoT is your insecure network services. So it covers all the network services including device, cloud, web and mobile. So obstacles in this like unnecessary ports are open. So we have seen that attacks on this open device ports. Okay, so unnecessary ports are open, then ports exposed to the internet. Okay, that's why it is easy to attack on these ports. And network services vulnerable to the denial of services. That means multiple requests are sent to the user. So that means at that time that it is easy for the attacker to attack on this device. Then what are the solutions for this? So we have to minimize open network ports. That unnecessary ports are open, so we have to minimize that open network ports. Then we do not utilize that UPnP. That means we do not expose this open ports to the internet. Then we have to review network services for vulnerabilities in case of denial of service attacks. Okay, so these are the some network services vulnerabilities like malwares are there, social engineering attacks, outdated or unpatched softwares are there, misconfigure firewalls, operating systems that allow or have default policies that are enabled. Okay, and next vulnerabilities for the IoT, lack of transport encryption. So obstacles in this like sensitive information is passed in a clear text. So your SSL or TLS at the transport layer, it is not available. Okay, or it is not properly configured. So we have to provide solutions like we have to encrypt that communication between the system components. Instead of passing that sensitive information in the clear text, we have to encrypt that information and pass between that components. So we have to maintain the SSL or TLS implementation. So do not use proprietary encryption solutions. Okay. So transport layer vulnerability, that means we have seen that SSL and TLS are not available. Okay, so we have to use proprietary encryption protocols like Kerberos, AES, DES, RSA for this security or for the encryption. And the next vulnerability is in the IoT, like privacy concern. It covers all the components of IoT solutions. So obstacles like too much personal information is collected. So we have to minimize the data collections, and that collected information is not properly protected. So we have to protect that information. We have to analyze that collected data. Okay. Then end user is not given a choice to allow collection of certain types of data. So we have to give end users the ability to decide what data is collected. Okay, so we have to maintain the privacy for the data. We have to minimize the data collection, and we have to analyze that collected data, and we have to restrict some access to that data. The next vulnerability is insecure cloud interface. So this vulnerability covers the cloud APIs or cloud-based interfaces. So there are obstacles like interfaces are not reviewed for security vulnerabilities. So we have to provide the solutions for these obstacles like security assessments of all the cloud interfaces. Weak passwords are there. We have to provide the strong and complex passwords. We have to provide the two-factor authentication for that. And seventh one is like insecure mobile interfaces. So insecure mobile interfaces like there are weak passwords are there, no two-factor authentication is implemented, no account lockout mechanism is there. So we have to provide all that. That means we have to implement the lockout after failed login attempts. We have to implement the two-factor authentication. We have to provide what we require. We require the strong and complex passwords for these interfaces. Then next vulnerability is insufficient security configurability. It covers the IoT device. Obstacles like yeah, we have seen that the password security options are not available. So we have to make sure that security logging will be available. Then encryption options are not available. We have to allow the selections for encryption options. No options to enable security logging. So we have to notify end users in regards to security alerts. Okay, we have to provide the security mechanisms for that. Ninth one is your insecure software firmware. So update servers are not secure. We have to make them secure. Device updates transmitted without encryptions. We have to provide encryption mechanisms. We have to verify the updates before installation. Device updates are not sign in. So we have to sign in that updates. We have to verify updates before the installation, and we have to secure this updated servers. Next one is your poor physical security. It covers the IoT device, poor physical security obstacles like unnecessary external ports like USB ports. We have to minimize that ports, access to operating systems through remove media. So we have to properly protect the operating system. Then inability to limit administrative capabilities. So we have to include the ability, we have to limit that administrative capabilities for this physical or for this IoT device. Okay, so these are the requirements, these are the vulnerabilities in the IoT device. There are some security challenges are there, or some security requirements are there, like authentication, data confidentiality, access control. We have to provide the authentication. We have to protect the data from external tampering and the unauthorized access. That is data confidentiality. Access control is there. We have to restrict the access controls, trust management, availability of resources, secure storage, secure software deployment, flexibility and adaptability is there. That means that IoT device move around the physical environment where it needs to interact with the devices of different type over various networks. Then scalability is there, tamper resistance is there. Okay, so these are the security requirements. Okay, these are the security requirements. We have to follow this security requirements based on the vulnerabilities on the IoT device. Then there are some challenges for secure IoT. This challenges like wireless communication, physical insecurity, then identity management for IoT device, secure interaction with or within the IoT devices, privacy and distributed access controls, end-to-end security is there, privacy is there, security structures are there. These are the IoT challenges like web interact threats, identity management and dynamism, inconvenience and cost, okay, lack of standards, okay, or attacks in the different layers. So different layers of IoT like MAC, it is the sublayer of the data link layer. So attacks like spoofing attack is happen at the MAC layer, man in the middle attack, event dropping at the network layer, routing loop, wormhole attack, network partitioning, denial of service attacks, incorrect or at transport layer, send a wrong data if it is not enabled or if it is not configured properly, then incorrect control packets are sent if that TLS or SSL is not configured properly. Okay. Then how to secure the IoT devices, like using secure boot, using authentication. We have to provide the uh, authentications to the users, like we have to provide the strong uh, passwords or strong access to the users. Then we have to protect the ports, we have to minimize the open ports. If it is unnecessarily open, then we have to minimize the ports. Then we have to secure the storages, secure connections. Okay, so these are the key elements in IoT security. Okay, key elements of IoT security, like identity establishment, access control, then data and message security, non-repudiation and availability, security model. Okay, so we have to these are the key elements of IoT security. Okay, that is first one is your identity establishment. Identity establishment, it uses the public key cryptography. Okay, public key cryptography for the identity establishment. Like whenever we are going to build a secure identity between the two communicating entities. Okay, two communicating entities for data transfer, that is called as identity establishment or authentication. So we know that any identity or identity in the communication can be a single device or a single user, or it is a set of users that can be any organization. While identity establishment, it confirms the source of electronic data or documents that is going to be transmitted over the network. For any authentication, private key cryptography and public key cryptography can be used for the identity establishment. Okay, and next one is your access control. So we have to define the boundary of data accesses for devices. The data access is done by the authentication. Okay, that means this mechanism specifies which data is accessible to which entity in the network. Okay, so we have to restrict or we have to limit the access to the resources. And third one is your data and message security. So this data and message security, in that we are going to use the DES or data encryption standards. So data and message security is concerned with three source issues, like source of data should be authentic, detection of any modification in the data, and data must be private. Okay, so the data can either be residing on a local and or the cloud storage or in a transmission phase of over the internet. Okay, so any modification, insertion or duplication of data must be avoided to maintain the integrity of data. The fourth one is non-repudiation and availability. So repudiation means rejecting the fact that one entity has sent and received the message. Okay, so because of non-repudiation, when a message is sent, the receiver can prove that that sender has sent a specific message. Okay, like example like blue ticks on WhatsApp. Okay, or that sender can prove receiver has received this message. Okay, so this is very important in case of security of IoT devices for pinpointing attack again. Okay, so rejecting the fact that one entity has sent or received the message and make all resources available and updated. And next one is your security model. So this security model for IoT represents different features that should be followed by the IoT applications. Like that security model of IoT can be represented by a cube with the three dimensions. Three dimensions that represent the security, that is your authorization, trust, that is your repudiation, and the privacy. Okay, so these are the three features, or what we can say, these are the three dimensions based on that security model is represented. Okay, so this is all about your key elements of your IoT security. Okay, so from this like a security model for IoT, we have seen that the security, authentication, confidentiality, integrity, trust, reputation. Okay, so we are remaining from this unit number 4 with the like use cases and the what we can say, this use cases and misuse cases, and we are remaining with the thread modeling and the some basic points. Okay, misuse cases in IoT security. We are remaining with only one point from this unit. Okay, so that's it for today's session. We will stop here. Thank you.